Sweet. So this is going to be a quick little live video of me going through and setting up the communication between, we have a serial connection, so you can see my screen. We're going to be working in Arduino, and then we're also going to be working in Python. And the goal of this is to set up this bot file. So I'm just going to go ahead and launch Atom right now, so we have that on the screen. And I just wanted to record this so that I'd have it as kind of a learning experience of how I go about doing different projects and thinking things through. I think it's super important to have kind of a real world experience of working with technology. This is a project where we're going to be applying it to the game of checkers. So I've got, let's see if we have kind of the diagram for this project. See if I can share it here quickly with you. So here's the diagram of the project. And you'll see we have two NeoPixel strips connected into an Arduino, and they each have 8 LEDs. We have an 8x8 matrix, and what we're going to be doing is translating moves for checkers using an AI GameBot and the Minimax algorithm. We're going to be translating those outputs into coordinates for this physical game, and this is just one axis for the game. And essentially what we want to do is be able to take the Python code for checkers and the Minimax algorithm, and we want to be able to send that information serially to this controller and then light up the corresponding row column pixel and have color control and all of that. So this is an RGB NeoPixel strip. There's 8 of them on this one. I only have one plugged in right now. And that's just because I want to, for the purpose of this video, is just work through getting the serial connection working so that I can light up a single NeoPixel strip. And I've got a ton of demo code and things like that I'm going to be looking at. So we've got the communication post between Arduino serial. So let me see. Communication between, let's see. And then this post here is a good one. So a lot of projects that I've worked on in the past, this is a client project that I am guiding him through. And something that I don't think people really talk much about is that this is kind of the process. Like, you have to sit here, and it's not like, it should be fun if you want to get into engineering, right? You should want to sit here and solve problems, but it isn't as simple as just going on the internet, downloading some files, and you're good to go. What I want to do is share with you a project that I have on the Learn Robotics blog. And this project is the communication with Python. So let me see if I can pull that up here. Communication, Python. And what this does is it allows you to connect your Arduino controller or any serial controller between Python and the IDE. And there's a lot of cool setups in here. There's some sample code if you want to download that. But really what we want to do is just communicate. So my goal with this is to use this starter code right here and start building out this basically building out this control code for the game. But in order to do that, we need to be able to even just control a single NeoPixel, really any of these NeoPixels, with a command serially. And so this code is just sample code for lighting up a simple LED. So being able to turn the LED on and off with Python. And what I want to do is convert this code into code that I can use with the NeoPixel. And so what I need to do is, essentially what we're going to do is use a 1 and a 0 right now, and just we're going to pick the pixel we want to use. So I'm just going to go ahead and grab this port. So it's, let's see if we can just grab the name here. So this is the name that we want. And this is something that people get really hung up on. is errors and copying stuff. So like if I were to run this code right now, it's not going to work. Let's go ahead and do that. And that's because this is set up for Windows. So we'll cd into our actual desktop because that's where this GameBot folder is. And then we're going to go into AI GameBot. You'll see all the files here, match all the files over here. And what we're going to do is Python 3 into botpy, and it's going to die, right? Because there's no COM3 port. And so the fix for that is to use the Arduino port name. So whatever you're connected in, USB modem 14201. Let's see if that works. Now this may die again because I'm playing with it in Arduino. So we'll just see if that fixes it. If not, we will debug it because that's kind of the point, right? The point of engineering something new is to figure out how it works. So let's see if we can run that. So serial has no attribute. Serial, I may need to install that serial module. So let me see if we do a pip3 install serial. So we already have it. Let me just do this quick little update. See if that fixes it. And obviously I don't usually narrate while I'm working on this. I'm usually pretty quiet and focused. So if I don't narrate everything that I'm doing, hopefully that'll still be valuable. You can kind of see the process that I go through. But like these projects, they're not 2-minute projects where you just download some code and you run it and it works. Like you actually have to sit here and figure out what you need to do. And that's kind of the point. So we'll make sure that let's not run that again. Let's go to bot. Okay, so now we need to figure out line 4 dev USB modem 1402. Let me just make sure I'm not playing with it over here. So we are good on this side. And let me actually grab that Arduino communication code. So you'll see it'll have it here with the port. And a lot of times what we can do is use what we have already used in the past. Let me see if I have that file in here because I've been playing with it. Pixel test. Let's see if we got it. This might be a good starter file. Let me see if we've got this raw file to use. Should have this on my computer somewhere. That's what I'm trying to find. Serial. Okay, so I've got the Arduino file now. It's this Arduino sketch. And essentially all we're doing is we are just setting the LED, setting the LED as off to begin with. And then we are just checking to see if the serial communication is available. And that's pretty much all I want to do right now is let's see if we can actually get that going. I've got a wire here that I can add. Just a simple LED test. So where do we have the LED on? here we have it on 13. You can use the built-in one. I'm going to actually use this red LED, and we'll just plug it into pin 7. Obviously, if you don't know what you're doing, I would recommend unplugging this. But for sake of sanity, I'm just going to go ahead and plug it in. And we've got it on 7. Let's just go ahead and update this new sketch. And we've got USB modem. Let me see if we have, let's save this. USB modem 14201. Let me see if that's the exact same way I did it here, because there's a reference to that port and you want to make sure that you have it in the correct format. So let me just grab this and let's try using quotes. See if that actually fixes it. Okay. So now we've got the right software coming in on here. We have this sample bot sketch over here. We are in the GameBot folder. We're just going to Python 3 to bot. All right. Serial port, timeout, module serial has no attribute serial. Maybe they changed that. That's something I'll have to look. Module serial has no module serial. That's an interesting one. Okay, so let's figure out what's going on. Okay, so it looks like they might have changed the package recently. So let's go ahead and this is pretty normal. I actually was doing a debug session on the Zoom with a client a few weeks ago, and they were wondering about Stack Overflow. And this is dude, this is normal. You want to try to find out the answer, and you want to find resources that will help you get the answer. So I'm going to go ahead and just pip3 uninstall serial. Yes. And then we're going to pip3 install PySerial. Okay. And now we're going to clear that, and we're going to see if that does anything different. Enter a 1 to turn on the LED and a 0 to turn the LED off. So when I hit a 1, this should turn on. And when I hit a 0, it should turn off. Ooh, interesting. Ooh, interesting. You entered a 1. Ah. Okay. So I'm wondering why it's not going off of the LED on 7. Did I not control LED on 7? Let's make sure we have the right sketch on here. There we go. Okay. So now we've got it working. I'm not sure why this one moved. So we should just, what I would like to do is set all these pins low. So digital right. Let's just do a quick little for loop in here. For int I equals, we start at 0, right? 0. I is less than 14. I plus plus. So what this is going to do is it's just going to say, because we have 13, we have 13 digital pins. So you can see we have all these pins right here. We just want to set the pins to low, all of them to low. And we honestly should just set them all to outputs. Pin mode I as an output. And I'm hoping that that will set this low so that we're not getting signal on the NeoPixel right now. Why are you still on? That's so bizarre to me. I was not expecting that to be on. I was expecting with that to be low, that it would have cleared it and set it off. Weird. Okay, so for now, weird. Let's go ahead and grab that NeoPixel library then, and we will start building this out. So you see how I kind of like go through this step by step, and let's upload this. Let's run that program again. We're going to send a 1, we turn it on. We send a 0, we shut it off. We have a 1, goes on, 0, off. Okay, cool. So the purpose of this demonstration is to show you that we are, funny enough, we are using Python to actually control this. So this is Python. This is the file right here, this bot.py. This is the file that we are running. And what we are doing inside of the sketch is we are looking for the serial connection. We are looking for some information. If it is available, we are going to take that data and we are going to write the LED high and print some information, or we will if it's 0, we will shut off the LED and we'll say that it turned off. So now that we have this base, code working, what we want to do is the next step is we want to, instead of controlling this LED, we want to control the NeoPixel. So we got to bring in some stuff for the NeoPixel because we know how to control the NeoPixel by itself. We're going to use Adafruit's library. Super, super easy to use. I'm just going to define one NeoPixel for our row, and that is going to be on pin 2, and it has the number of pixels is 8, and that means num pixels. That's right, num pixels. Okay, and that looks good. So that basically says that we have this 8 NeoPixel strip on pin 2, which is this blue wire, and the other 2 wires for the strip are plugged into 5 volts and ground, and they're going 5 volts ground into this controller. And we are actually powered off of USB, and we're sending data off of USB. So this is 5 volt power, and this is also a data line that we're using serially. So just want to be super clear about that. So now that we have that, we instead want to, at the beginning, we want to begin our pixels. So we will also begin the serial monitor. We are also going to begin the pixel. And now that we have the pixel object, and we're probably going to want these globals to control color. So we're going to do some NeoPixel globals, and these are going to be for our colors. And we can go ahead and we can do a set color if we want. Set color, this is kind of useless the way it's set up because it just prints out information that we don't care about. So I think what we want to do at the beginning is actually clear the pixel so that pixels are clear. And this is going to clear the pixels. Let's actually see if that works. Let's go ahead and make sure I didn't typo. Okay, upload. I'm hoping that, I'm not sure why, you know what it could be? It's because this is probably running. So now let's go ahead and upload. So we got to figure out why we don't have, this is on 2. That's correct. That's correct. This is correct. This is correct. I wonder if we have to just set the pixels as being off first. I was hoping that clear though, and this is where like going into the library would make a lot of sense. So this is that NeoPixel. So we should see where there should be like a GitHub. So I thought there was one like clear. Fill the strip with 0. So like that's what I'm trying to figure out why. Clear, show, begin, transmit data. Maybe it's that for loop. I don't know. So let's go ahead and get rid of that because we're not using the LED anymore. We're not using that. Let's see what that does. So I'm just playing around with a couple of ideas here. Just want to move this working method out of loop and see what we're going to do here. It's so bizarre to me that we can't, and that's pixels is set up on R to get that to shut off. It makes me think that we don't have full control of it. And that's what's weird to me. I was half thinking that maybe we have to initialize it as being off, but let's see actually. Interesting. Okay, so, well, that's something that we're going to have to figure out is we need to be able to clear the pixel on startup. And I'm kind of curious to see if any of my other NeoPixel code does that. So let me try that. This is some code that I was playing with before. I'm just going to change this to 2. I'm just going to test code. Just make it NeoPixel. Just go ahead and update that. So for whatever reason, it's still getting signal on that pixel, which is so weird to me. Enter the position. See, so we can actually change it. But I'm having challenges getting it to start off. So this is something that we're going to need to figure out. And it could be something obvious that I'm just not seeing right now. So interesting. So what I want to do is, while the serial is available, we're going to read the serial. We are going to get the data. So if it's 1, we want to, instead of turning the LED on, we want to turn the NeoPixel. So we want to set the NeoPixel, which I have some code for. And then we want to, and we can make this fancier later as we start building this out. So I'm just going to NeoPixel position turned on. So we are going to do this first position here, which is actually position 0. And we are just going to use the globals to set the color. So for now, it's just going to be red. We will show it. And then if we are 0, then we are going to take that position and we are going to be off. And I do want to make it very obvious what we're doing. Clear. And it could just be that I need to figure out how to show hide a single pixel. And it could just be set pixel color, fill, clear, can show. I wonder if there's one that's like hide, nope, off. So we can kind of play with that library. Clear hasn't really been doing anything. So serial. Okay, so it's just turning off that pixel, because we can turn it on, but we need to be able to turn it off. So enter the Google machine, turn off NeoPixel. So I'm going to look this up. I'll be back once I have some. So I found this interesting thing from Lady Ada herself, where she says to call show after clearing, which is weird to me. Pixels are show. We'll try that. Okay, so now that's on. So 1, 0. Imagine that. Lady Ada herself knows how her own library works. Okay, so this is where like going through this process is a process. And I just wanted to take some time to kind of literally work through in real time. Yeah, I paused the video a little bit here and there, but honestly, like this 27-30 minutes is like normal. So if you're not willing to sit down and work through and solve these problems and use information and compile it and put it all together and come up with a synthesized solution, then robotics probably isn't for you. It's really not as easy as maybe one might think it would be, because you're constantly trying to figure out how all this information goes together, right? And so the problem is, how do we light up a coordinate, or really the high level problem is, how do we create this GameBot here where we are demonstrating row column coordinates on these NeoPixel strips, receiving calculations, computations from an algorithm written in Python. And so the first baby step we need to do is be able to communicate serially with just a simple LED. Now we need to communicate with the NeoPixel. So now that we can do that, we can set a position and we can actually light it up, and now we can actually shut it off. The next step is how do we get an index of this strip, light it up, and turn it off. So that's kind of how I would work through this. And maybe I'll go ahead just for kicks and work through that quickly now. My initial thought is in the Python code where it asks enter 1 to turn on the LED and 0 to turn the LED off, we could do something where instead we ask which LED, which Neo pixel position to light, something like that. we get the input and we print it out. So I'm just going to comment that one out. And then what we do is when we enter in the variable, we just write that variable and we have to read it in. And we're going to be reading in a bunch of different values here, but instead of entering in and sending it over as the state, we will enter it in and send it over as the position, and we will automatically light it because we only care about lighting positions of things we only care about the position of things we want to light, not necessarily the position of things we don't want to light. So if we're sending over an index, odds are we want to light it. So that actually will probably be okay. So we should just take whatever this variable is and just encode it. I'll have to play around with the Python syntax of this, but that would be my initial thought. And then we can just put like NeoPixel. Let me just comment all of this. I don't even know where that is. Toggle comments. But I would do something like this where we just take the variable, we print it out, and this becomes the position. And we get the input as a string. And then what we do is we write it. And then if the data, basically then we just need to set the data to the value. That's really what we want to set it to, and send it over. So I'm going to play around with how we want to do that. But this is kind of the process that I wanted to share with you of taking in an index from one piece of software to another piece of software, then demonstrating it in the physical world. That's where we're at for now. So I'm just going to play around with some of these different ideas on how we may want to set this. And I'm probably just going to work on this. I'll leave it recording and probably not going to be narrating as much unless I find something interesting to share. And really just, getting to see the behind the scenes process of putting something like this together. So we're storing this through data read. We have data. So then my thought is data is now going to be the pixel position. I don't know if we can do this. This may actually not be happy. How did we have it before? Maybe we can actually. Okay. Oh, I didn't save that. That was why. For I'm thinking maybe that is what we need to do. Code position. Please encode to bytes 4. Yep. I don't know if they allow you to do that. They allow you to write. They should. We'll try it. If it throws an error, we'll have to convert it. Probably don't want to put that in there. I probably want to put it down here. Finally. Oh, then it turns back on. That's what I don't understand. It could be, maybe it's because of this. I don't know. Okay, so that tells me that because of this position, something in here, meaning basically while it's available or while it's unavailable, because it's not available, then it was just jumping down and setting that position. So my guess is if I remove this, it's going to come back on. Let's try that. Yep. So that's just because position there is null. So it should shut off again. So now we've got a nice clear strip to use. And now I'm going to try sending that, converting it into an integer, using it. Okay, so it was a 4. Kind of surprised. position equals 0. Position equals 0. I wonder if I need to set this up here. Okay. Let's get rid of these prints. Did this port give out on me? Let's see. Should be good. Saying resource busy. So we'll get rid of that. We will upload again. I'm wondering, let's play hack the system here and try out a theory. Huh. I wonder. This data is still a string. Oh, I think I know what I did wrong. Let me check my Python file here. I need to string encode that position, not convert it here. Okay, so now we have this position 52, which was I entered 4. So it's the conversion wasn't quite correct. So let's see what the data comes in at, and we'll make some adjustments. Data 52. Wonder if they have something similar. I wonder. Let's see. That looks like a stupid idea, but let's try it. Oh, could because I have this on. Serial parse int. Can read the integer using. That might be interesting. Huh. Maybe that's what I need to do instead. Okay. That's right, because the Python file is messed up. Okay, so let's try that. Let's see if we try something. Gotta try that way of formatting it. So this is the syntax. See if we can encode it that way. That would be great if that works. Nice. Whoa! We just got something lit up. So 1, 0, 1, 2, 3, 4. Ha! Nice! Woo! Okay, so you can see how something like this will just like, it's a process. You'll notice that I didn't just have this answer right away. It took me a lot of like investigating and thinking and going through the process. The interesting part is I should be able to keep doing this. So 5, that's pretty cool. And what I need to be doing is every single time we need to be clearing. So maybe I need to have in here like a, what I'll call like a prev data. And what I'll do is I'll make sure that and prev data does not equal data. That way, so what I need to do is set prev data equal to data. That way, what will happen is if the new data doesn't equal the old data, then it should shut off the old one. So we will move the delay down here. And I should re-upload that. So we're just passing the hour here of me playing with code. 4. Okay, so now we've got 5. Now we've got a challenge with, so maybe this needs to be if data equals previous data. Let's do that. I got a bracket. I mean a paren. Let's see. Okay. Okay. So what I'm seeing is this isn't being set correctly. So now what will happen is we've got these lingering pixels from the previous iteration that need to be cleared out. So I'm almost wondering if maybe this needs to happen here while it's available. We need to clear it out. So let me try that. See if that works. Okay. So 2. Boom. We have, let's make it 5. Boom. Ha, imagine that. Okay, so the solution is you want to clear every single time you're, because what we're doing is we're sending information here. We're sending information serially, and that means this happens when the serial monitor is available. So every time it becomes available, we want to clear the pixel. So let's go to 7. Boom. And this is indexed from 0, by the way. So this is 0, this is 7, even though there's 8 of them. It's indexed from 0. And we can change that in the code, but we're not going to, because in software we start counting at 0, and so I don't want to have to translate it twice. So we'll just make it standard in our axes. Okay, so now we know my computer's going to be dying, but for now we know exactly how to send positions serially by capturing a number from the serial monitor. And what I should put in here is if the data is greater than, this actually needs to be greater than, data is less than 8. Because otherwise we do need to clear everything. There isn't anything to display. So let me just add that quick little else in here. I don't know if this will actually do anything. It should, but default state should be nothing is on. So nothing should be on. And then if we go in here and we run it, this again is just sending data from the serial monitor to this LED, this NeoPixel LED. I have the color set to red. This is RGB, we can change the color, but I just figured we'd take, a really obvious color to use. So now if we type in, let's say 9, I'm hoping that everything shuts off. Yep. Okay, cool. Because there is no index 9. If we index 0, we should be this guy. Let's see what happened. Oh, I found it. It's because we need to be greater than or equal to 0. Okay, so this is why we test it. So now if we enter in 0, it should turn on, and it was going to turn on because the previous value was 0. So if we go 9, we should shut everything off. If we go 0, it should go back to this guy. Yep. Now we have 1. Now we have 2, which is the next one. 3, I'll get this one. And then 4. And then 5. And I'm typing these in. You can't see that, but I'm typing these in. Then we have 6. And then we have 7. Okay, so they all work. I'm going to go ahead and type in an 8 and just shut off. But yeah, this is where we're at with this particular section of the project. A lot of, trial and error, a lot of testing. It all came down to this one little encode that I managed to find, reading through documentation. The thing about working in software isn't necessarily knowing exactly every little syntax. It's really, how do you think about solving problems? And so, like, real world debugging, this is something I just want to quickly bring up on here. And I'm just going to actually erase this. So, like, we have an idea of what we want to create. And a lot of the work that I do with my clients and when I'm working at companies as a consultant, a lot of times what I'm doing is I'm presented a problem. So we have this problem. What is the best way to solve this problem? And how would we go about creating like that process of going basically from 0 to having something that works and presented to a requirement, kind of like what we have here. And you can kind of, honestly, I'd encourage you to just go through and even on 2x speed, like rewatch this training and see kind of my process, because you'll notice that down here, I have the answer, but coming in at the top of this process, I didn't have the answer, right? We didn't have it solved. It became solved down here. And what I did was I micro-stepped my way into these like little things. Like you'll notice we started out with the LED. Can we communicate serially with the LED by turning it on and off? So can we go on and can we go off? That was the first project that we did. And that was just to prove out, like, do we have communication? Do we have connectivity between the controller? And can we talk to it with Python serially through the IDE? Then you'll notice the second thing that we did was we had to get this LED strip, the NeoPixel Strip, set up. And we wanted to be able to turn on one of these actual positions on the strip. And we just, we started building out from this example code and having the next step be, can we turn it, this was a 1 or a 0, can we just hard code the position? So this is where we hard coded the position. And we can set that inside of the Arduino IDE. So inside of the Arduino file, we just set this position to whatever position. And then were we able to send it a 1 and a 0 to control the state? So we did a state control over here on the actual pixel for the NeoPixel strip. And then the next step was, how do we actually just ask for the index? So we asked for an index through the Python file as an input. So an input. And the cool part is like taking this input, and I'll actually come back to that thought, but remind me, I'll go back to this spot in a minute. But what we wanted to do is we wanted to say, like, which position do we want to light? We wanted to say index 3, 0, 1, 2, 3, and now we're lit up. So now we have that working. The next step that I can see us doing is, instead of asking for the input, we want to just set that variable. We want to set a position variable within Python. Instead of asking for the input, we're just going to set it. And now, honestly, this is super easy. All we need to do is, instead of asking for the input and printing it, I'm just going to say position's been set. So we'll actually just comment all of this out, and we'll write it up here. Position equals 2, so that'll be 0, 1, 2. That'll be this guy right here. And I'm just going to print saying position 2 has been set, and save that. We're just going to send it back over. This is what sends the info to the Arduino. And we'll cancel out this project. We'll rerun it, and we should just automatically see this guy being set. And see, this is where, okay, interesting. So this is where we would go back through and start running things again. So sends the info to our int object has no attribute encode. So that's interesting. So now what we need to do is we need to actually set this as a string encode. And my guess is that will fix that problem, and this guy will light up somewhere over here. Let's see. String and int object has no attribute encode. How was it set up before? Oh, that's right, because we just string encode. Duh. Okay, cool. So we can string encode the position, because that is already set to a string, right? So we cast it as a string, and then we encode it. We do a string encode. Let's see if that fixes it. Debugging on the fly. Position 2 has been set. I don't know why it's printing out a gazillion times. Let's see what's going on over here. Interesting. So then, so that's the next step, is we would need to figure out, how do we set the position automatically in Python by sending an actual value. So we need to obviously make sure we're setting it in the right way. My guess is that this is what we need to do right here. So let me just get rid of all this other crap. And let's put this up here. Shut that off. I don't know. I think that's the way you do it in Python. Let's go ahead and cancel that out. Position 2 has been set. I wonder if we just hack the system again. That works, and that will tell me that what we need to do is figure this piece out, and we could probably just rewrite it. So all I'm doing is just micro-stepping in to getting things to work. I'm not sure why. Oh, is that why? Yeah, that's probably why. Because I'm trying to pretend, because I'm going back and forth between Python and C++ and using semicolons. And it's expecting an int. I would guess it was that semicolon the whole time. Okay. Int object has no attribute encode. Can I just send this without encoding it? I wonder if it will let me do that. Nope. Nope, it don't like that. I think it's because it's expecting an int over here. So if that data comes in, turn it on because we have some data being shown. Interesting. So again, that's going to be the next problem that needs to be solved. My computer is going to die, so we are going to wrap it up here. This is going to be the next problem that we need to solve. Once we know how to set the position directly from Python to the actual index, we'll be able to create a variable from the game and then connect the game to this output. And then we'll just repeat this exact same thing for the column. So we have one that's for rows, and we have one that's for columns. So it's kind of like an X and a Y and an X, and it's actually set up that way. And that's pretty much it. That is the process. I did want to record this just to show you, like, not all tutorials are just copy paste and you're done in 2 minutes. This is really what goes on behind the scenes when you're developing these kind of projects. So I hope this was helpful. Feel free to rewatch this again. I'm going to be playing around with debugging or adding in the next step with the actual position. And I'm probably just going to go through and let's get this working again. See if we can do that. Get that working. Get it cleared. Get it back to current state. Part of doing this is to make sure that. Right here. Which NeoPixel do you want? So 4, 0, 9. Clear. Cool. That's pretty much it. So that's where we're at right now. Next phase will be setting the position in Python, and then following that, we will be connecting. So step 5 will be connecting the AI to the actual Python. So the AI will be setting the position, not me hard coding the position. It'll be set by the AI. And then we'll have colors, we'll have fun things like that. But here is just a quick look inside of this project. I suspect there'll be another part coming soon. If you enjoyed this, please like this video and subscribe. I've never done this style video where I'm just doing real-time coding and real-time electromechanical, like, hardware stuff. So if you do like it, just like it and let me know in the comments. And until next time, see you later.